The way a computer does its tasks are very much similar to how we humans manage and carry out our tasks. In this video, we will be talking about time complexity. But in order to understand time complexity, let us imagine a scenario. You are a worker in a mailing company. One day, an unfortunate accident occurred and all the letters in the company's delivery truck was scattered. After some time, the company managed to gather all the letters, but it was still a mess. You were assigned to sort the letters out alphabetically. So you ask yourself, how should I sort and organize these letters? So, for the sake of explanation, let's just first organize a few letters. Say these here are the letters. We first check if the two letters are in order. And if they are in order, we leave them as they are. But since the letter C clearly goes first before the letter Z, so we swap them. Then we compare the second and third letters, and since F goes first then Z, we swap them again. Then we swap the next elements, so we swap Z and A, and then we get this. Notice that they are still not in order. So we did what we did earlier and we go back from the start. Then we start again from the start. And we do this again and again until we get them in order. So what we did here is what we call a bubble sort. It's a sorting algorithm. It's simple but slow. Now, bubble sort are just one of the many examples of a sorting algorithm. It's just a strategy. We can also use another sorting algorithm called insertion sort, which basically just looks like this. Insertion sort is similar to bubble sort. It's also an example of a sorting algorithm. Its objective is the same, which is to sort things out, but it uses just a different strategy. Now I'm just gonna say that I only showed sorting algorithms examples earlier in order for us to get a rough idea about what time complexity is. But now let's move on and somehow forget those. And let's focus on defining time complexity. As the saying goes, there are many ways to kill a cat, or in the context of computer science, there are many ways to do a task. But which one is the most efficient? What way is the most efficient way to kill a cat? Or in other words, what's the most efficient way to do a task? This is where time complexity comes in. Basically, in computer science, time complexity is a concept or a word that just describes an algorithm. It describes how much time it needs to run, but not necessarily an algorithm. It can be a program or instruction or a code. And that's just it. That's the definition of time complexity. Now that we define time complexity, let's go back to our example. Earlier in the example, we arranged the letters alphabetically by bubble sort and insertion sort. By analyzing these sorting strategies in a deeper site, we can actually know which one is faster and which one was slower. In computer science, one of the most common concepts related to time complexity is the big O notation, which is a more formal way to describe time complexity with all the mathy equations and all. But ultimately, as defined earlier, the key concept in time complexity is the question, how efficient am I in doing this task? Now that we understand the concept of time complexity, let's talk about its importance. So the importance of time complexity is that it tackles efficiency. It can be the reason for many companies and developers to have efficient programs so that it could be more advantageous and we could do more stuff done in a shorter period of time. In games, we could have faster and efficient lag-free games, or even just in a simple video editing software, we could have a video editing software that renders videos really fast. And that's just it. That's just what time complexity is all about. But before I end this video, I want to talk about time complexity in a metaphorical or in a sentimental way or a different point of view. We can talk about time complexity as it can be seen every day in our lives. We can talk about how efficient we should do our assignment so that we can do things faster. Or should we say, in doing our chores like washing the dishes, what should we do so that we can wash the dishes really fast? And even the concept of the study less, study smart, um, that we should study smart and not just work hard. And also in simplest things like taking a bath. If we want to save some time, how should we take our bath so that we could save some time? And to end this video, one thing that we can learn from the concept of time complexity is that in life, there are always better solutions to anything, that we shouldn't settle for inefficient strategies in solving our problems or tasks.